Hello, and here we meet again at the FinetLink channel, and we are studying about the basic configuration part 2. And as a reminder, the objective of this material is to configure devices using security best practices. At the first part, we configure initial setting on a Cisco switch, and we even configure switchboard to meet network requirements. Now, what we will do is that we will configure secure management access on a switch, and we will configure basic setting on a router to router between two directly connected networks using the command line. And at the end, we will verify the directly connected networks by using the verification commands. So as for the security access remote, first of all, you might know that you may not be always able to have direct access to the switch when you will need to configure it. So in this case, we will need to be able to access it remotely, and it is imperative that you access that in a secure mode. The Telnet uses TCP port 23, and it is an older protocol that uses unsecure plaintext transmission of both the login authentication for user password and the data transmitted between the communication devices. A threat actor can monitor a packet by using the Wireshark, and here is an example that the threat actor has captured the username admin and the password CCNA from a Telnet session, which means that the Telnet is not secure when we are trying to access remotely our devices for configuring that. So in this case, we will need the security shell, which is a secure protocol that uses TCP port 22, and it provides a secure, which means encrypted management connection to a remote device. Security shell should replace the Telnet for management connections, where the security shell provides security for remote connection by providing strong encryption with a device which is authenticated with username and password, and will also be able to transmit data between the communication device in secure mode. Here is an example that shows a Wireshark capture of a security shell session. As you can see, the threat actor can track the session using the IP address of the administrator device, but unlike the Telnet, he is not able to see the username and the password since they are encrypted. To enable a security shell on a Cisco switch, you must be using a version of the iOS software including cryptographic features and capabilities. By using the show version command on the switch, we will be able to see which iOS of the switch is currently running. And you can see that on the file name that includes the combination K9 as it is here, which means that supports cryptographic or encrypted feature and capabilities. But before configuring the security shell, what you have to know is that you minimally need to configure it with a unique hostname and the correct network connectivity setting. So the steps for configuring a security shell are 6 of them, and the first one is that you need to verify the security shell support by using the command show IP security shell. With this, we will be able to verify that the switch will support the security shell. If the switch is not running on iOS that supports cryptographic feature, this command is unrecognized. And the step 2 will be to configure the IP domain, where the IP domain of the network by using the IP domain name command followed by the domain name global configuration mode. And in this case, we are using the domain name as cisco.com. And the step 3 will be the generate on RSA key pairs. Not all the version of the iOS default to Security Shell version 2 and Security Shell version 1 has known security flaws. To configure the Security Shell version 2, you have to enter a command at the global configuration mode known as the IP Security Shell version 2. Generating an RSA key pair automatically enables Security Shell. By using the command cryptokey generate RSA at the global configuration mode, we will be able to enable the Security Shell server on the switch and generate an RSA key pair. When generating this case, the administrator is prompted to enter a modulus lang. The sample configuration in this figure, you can see that it will be 1024 bits. A longer modulus lang is more secure, but it takes longer to generate and to use it. So the best practice is to use this kind of length for the modulus size. At the step 4 will be the configuration of user authentication, which the Security Shell can authenticate user locally or using an authentication server. To use the local authentication method, you have to create a username and password pair using the command username followed by the username, the command secret followed by the password, and those will be entered at the global configuration mode. And here in this example, we are using as an authentication local method the username as admin and the password as CCNA. At the step 6, we will configure the virtual terminal lines. Since we will enable the Security Shell protocol on all the virtual lines by using the transport input Security Shell command in the line configuration mode, and the switch that we are using, there are 16 virtual terminal lines followed from 0 to 15, and by using the line VTY at the global configuration mode followed by the number of the virtual lines that we need to configure, in this case all of those 16 virtual lines, we will be able to enter in those virtual lines, and after that by using the transport input Security Shell we will enable the Security Shell protocol, and then by the login local line we will require the local authentication for Security Shell connection from the local username database. And at the last step will be the enable Security Shell version 2. Since I mentioned before, by default the Security Shell supports both version 1 and 2, but when supporting both versions, this is shown in the show IP Security Shell output as supporting version 2. In case you need to enable Security Shell version 2, we need to use the command IP Security Shell version 2 in the global configuration command. So after configuring the Security Shell, we need to verify if the Security Shell is operational. So in this case, we are using this as an example where we have a PC and a Security Shell client such as PuTTY, which is used to connect to a security shell server. Let's assume that we have this following configuration where we have the security shell which is enabled on the switch 1. We have the interface VLAN 99 for the switch virtual interface with the IP address of 172.17.99.11 on the switch 1, and we have for the computer with the IP address of 172.17.99.21. And here we are showing the PuTTY setting for the PC1 to initiate a security shell connection to the switch virtual interface VLAN in the address of the switch 1. When connected, the user is prompted for a username and password as it is shown here. By using the configuration from the previous example, we will enter the username as admin, and as the password we will enter the CCNA as we created when we configured the security shell. After entering the correct combination, the user is connected via security shell to the command line interface on the Cisco switch now, and then to display the version of and the configuration data for the security shell on the device that we have configured as a security shell server, we will use the command as show IP security shell. And here you can see that security shell version 2 is enabled. So with this, we are ending the configuration above the switch where we configured the port with the duplex, the speed of the port, and auto MDIX, and we even troubleshoot the network access of the switch at the first part, and here we saw the remote access in a secured form. So now we will go and configure the routers, so which means that we are seeing the basic router configuration. And first of all, we will configure basic router setting. Cisco routers and Cisco switches have many similarities. They support a similar model operating system, similar command structure, and many of the same commands. So in addition, here we will listed to configure how we can configure the host name of the router and how we can configure the passwords as it is shown here, which means that we have to enter at the global configuration mode with the configure terminal command, and then we can name our device by using the hostname command followed by the name that we want to for the device, and then we can enable the password for access mode by enable secret followed with the password, and then we can configure the line console, which means that we have to enter at the line console. Each device has only one console port, and that's why we are using line console 0. Then we will have to configure the password for the console by using the command login, which means that we are making the password able for that, which means that we are activating the password, and then we have to enter at the virtual lines. In this case, we are configuring 5 virtual lines. Same, we have to configure the password, and then after we have configured the password for all of those access, the privilege access mode for the line console and a virtual terminal, what we will need to do is to encrypt all this password. And after that, we have to configure even a banner to provide legal notification of unauthorized access for the device as it is shown here. This can be done in the global configuration mode with the command banner, message of the day, and then followed by the message between those two hashtags in this case. The hashtag can be different signs, but it's important that between those two similar signs there would be the message that we want to add. And after all those kind of configuration are done at the router, it is important to save our configuration, which means that we have to copy our running config to the startup config, because the running config will be erased as soon as the device will be shut down, which means that we have to copy them at the NVRAM memory, which is a memory not erased, non-volatile memory, it is called. And here there is a syntax checker which will show us the configuration that will be done at the router 1. So let's see, we are entering the global configuration mode and we have to configure the password for the privileged access mode. We have to configure the password for the line console, for the 5 virtual lines, and after that we have to encrypt all the passwords, enter the banner message, and at the end save all the configuration at the startup config. Now we will go and configure the router interfaces, but before that remember that we may have IPv4 networks and IPv6 networks. So in this case we are using a dual stack topology, which means that this network will be able for both kind of networks, IPv4 and IPv6, because one distinguishing feature between switches and routers is the type of interface supported by each. Here there is an example with layer 2 switches supporting the LANs, and therefore we have multiple fast Ethernet or Giga Ethernet ports, as you can see here. The dual stack topology in the figure is used to demonstrate the configuration of router IPv4 and IPv6 interfaces. And as you can see here, we have router 1 and router 2. Router 1 supports 2 LANs and router 2 support 2 LAN, and they are connected together with a link between router 1 and router 2 with a serial cable. So what we have to do is to configure the interfaces for the router 1 Giga Ethernet 0/0/0/0/0/1 and serial 010 for the router 1 and same for the router 2. So let's go and configure those interfaces, and let's see what we can configure on those interfaces. Since routers support LANs and WANs, they can interconnect different types of network. Therefore, they support many types of interfaces. So, for example, as you saw, they use Giga Ethernet interfaces with high-speed 1 interface card slots to accommodate other types of network interfaces. In this case, they use serial cables for connection between two routers, and they use Giga Ethernet interfaces for connecting LANs. To be available, an interface must have a configuration with at least one IP address, which means by using the IP address command followed with IP address and the subnet mask, we will configure the interface for the IPv4 network. And by using the command IPv6 address followed with the IPv6 address /prefix, we will be able to configure the interface with an IPv6 address for the IPv6 network. And then is the activation, which means that by default LAN and WAN interfaces are not activated, which means that they are in the shutdown mode. To enable an interface, it must be activated by using the not shutdown command. This is like similar to powering up or powering on the interface. The interface must also be connected to another device as a hub, a switch, or another router for the physical layer to be active. And what you can figure out in an interface is the description. It is an optional configuration, which means that in this case, the interface could also be configured with a short description with at least up to 240 characters, and it is good practice to configure a description on each interface because on the production network, the benefits of interface description are quickly realized as they are helpful in troubleshooting and in identifying a third-party connection and contact information. So based on the previous example, here are the configurations that we can do in the router 1. So at the router 1, there would be the interface Giga Ethernet 0/0/0, which this interface connect the LAN 1. And in this interface, we can configure the IP address of this interface, which will be the default gateway for the LAN 1, which means with the command IP address and the IP address and the subnet mask, we are configuring the IPv4 for this interface, and with IPv6 address followed with the IPv6 address / the prefix, we are configuring the IPv6 address for this interface. And then we can add even a description here with the description command followed with the information. In this case, we are saying that this is a link to the LAN 1. We will need to activate the interface with the not shutdown command, and then we have to exit from this interface, and now we have to go to the interface Giga Ethernet 0/0/1, and same, we have to configure the IPv4 and IPv6 address. We have to add a description, which means it's a link to the LAN 2. We have to activate that with the not shutdown command, and then we have to exit to go to the interface serial, which is 0/0/0, and is the interface that connects the router 1 with the router 2. Same here, we have to configure the IPv4 address and IPv6. We have to add a description which is linked to the router 2. We have to activate this interface, and then by exit, we mean that we are exit even from this interface, and in this case, we configured all the interfaces. And here is a syntax checker. This will be at the router 2, which will do the same configuration as at the router 1, which means that we have to enter in each interface and adding the IP address for the IPv4, IPv6 networks descriptions, and we have to activate those interfaces. And based on the network that we had a couple of slides before, there would be the IP addresses of the interface for the interfaces, and their IP addresses will be the default gateway for their network that will be connected on those interfaces. So let's see the configuration here. And as you can see, the first thing you need to do is to enter at the, so we are using the short mode interface G0/0/, which stand for the Giga Ethernet. Now we have to go to the Gigabit Ethernet 0/0/1. We have to configure here the IPv4 and IPv6 address. We have to add a description, which in this case connect the link to the LAN 4. And then we have to configure the serial 0/0, which is the interface that connects router 2 with the router 1. And each interface we have to activate them with the no shutdown command. Another common configuration of Cisco IOS router is enabling a loopback interface. The loopback interface is a logical interface that is internal to the router. It is not assigned to a physical port and can never be connected to any other device. It is considered a software interface that is automatically placed in an up state as long as the router is functioning. The loopback interface is useful in testing and managing a Cisco IOS device because it ensures that at least one interface will always be available. For example, it can be used for testing purposes, such as testing internal routing processes by emulating network behind the router. The loopback interfaces are also commonly used in lab environments to create additional interfaces. For example, you can create multiple loopback interfaces on a router to simulate more network for configuration practice and testing purpose. During our studies, we will use a loopback interface to simulate a link to the internet. To enable and assigning a loopback address is very simple. The command that you need to do is like when you are in the global configuration mode, by using the command interface loopback followed by a number, you will be able to enter in the loopback interface, and here you will be able to configure the IP address. Multiple loopback interfaces can be enabled on a router. The IPv4 addresses for each loopback interface must be unique and unused by any other device interface, as it is shown here in the example, where we will configure a loopback interface 0 for the router 1, and we will add an IPv4 address. And with this, so after we did the configuration on a router, there is no point in configuring your router unless you verify the configuration and connectivity. And here we will cover the commands to use to verify directly connected networks. And there are several show commands that can be used to verify the operation and configuration of an interface. Let's recall the topology that we use to demonstrate the verification of router interface setting. And here is the topology that we use to do the interface configuration. By using the show IP interface brief or show IPv6 interface brief, we will be able to display a summary for all interfaces, including the IPv4 or IPv6 address of the interface and current operational status. And by using the show running config interface followed by the interface ID, we will be able to display the commands applied to the specified interface. And by using the show IP route and show IPv6 route, we will display the content of the IPv4 or IPv6 routing table stored in the RAM. And you will be able to see even the identified codes for the routing table, where C will stand for connected or L will stay for local. So let's go and see those kind of commands. In case we need to verify the interface status, we have to use the show IP interface brief and show IPv6 interface brief as it is shown here. They can be used to quickly reveal the status of all interfaces on the router. You can verify that the interfaces are active and operational as indicated by the status up and the protocol up, as it is shown here in this example. A different output would indicate a problem with either the configuration or the cabling. In case you need to verify the IPv6 link local and multicast address, we need to use the show IPv6 interface brief, but by using the show IPv6 interface followed by the interface itself, which we need to check, we will display the interface status and all the IPv6 addresses belonging to the interface. Along with the link local address and the global unicast address, the output includes the multicast addresses assigned to the interface, which began with the prefix as FF02, as it is shown here in this example. In case you need to verify interface configuration, you need to use the show running config interface followed by the interface itself that you need to check. And here you will be able to display the current commands applied to the specified interface as it is shown here. And in case you need to verify the routers in the device, you will use the show IP route and show IPv6 route command to reveal directly connected network entries and the 3 localhost route interface entries as it is shown here in this example. The localhost route has an administrative distance as 0. And it also has a /32 mask for the IPv4 and the /128 mask for the IPv6. The localhost route is for routes on the router that owns the IP address. It is used to allow the router to process packets destined to that IP. The number C next to the route within the routing table indicates that this is a directly connected network, and when the router interface is configured with a global unicast address and it is up to upstate, the IPv6 prefix and prefix length are added to the IPv6 routing table as a connected route. The IPv6 global unicast address applied to the interface is also installed in the routing table as a local route. The local route has a /128 prefix, and the local routes are used by the routing table to efficiently process packets with the interface address of the router as the destination. We have even the filter show command output. Commands that generate multiple screens of output are by default paused after 24 lines. At the end of the paused output, the more text displays. By pressing the enter, you will be able to display the next line, and pressing the space bar displays the next set of lines. We use the terminal length command to specify the number of lines to be displayed. A value of 0 prevents the router from pausing between screens of output. Another very useful feature that improves the user experience in the command line is to use the filtering of show output. Filtering command can be used to display specific section of output. To enable the filtering command, we have to enter a pipe, which is a character after the show command, and then enter a filtering parameter and a filtering expression. And there are 4 filtering parameters that can be configured after the pipe. The first one will be the section. We show the entire section that starts with the filtering expression as it is here in the example. So in this case, we are showing the running configuration for the section only for line VTY. We have the filtering include. In this case, we will include all output lines that match the filtering expression as it is shown here. Here in this case, we use the show IP interface brief, and it's all this interface in all this information, but by using the show IP interface brief, by entering a pipe and that include only those who are up, here will be the output, which means that the serial 0/1/1 will not be shown since this interface is down. Another filtering will be exclude, which excludes all output lines that match the filtering expression, as it is shown here. By using the show IP interface brief, this will be the information. And if we will do the filtering as show IP interface brief followed by a pipe and then exclude unassigned, this will be the information that we will have. And the last one will be the filter begin. We show all the output lines from a certain point, starting with the line that matches the filtering expression as it is shown here. By using the show IP route, only those which begin with the gateway, this will be the information. And here will be a syntax checker that we will filter output for the show commands. And as you can see, by show running config section line console, we will be able to see the configuration for the line console only. Here we'll be able to see only for the interface that is down and for the interface that is not up. And by this, we are ending all the configuration, basic configuration for the router and the switches. Thank you for being with us. If you like the video, share it with your friends. And if you are new, do not forget to subscribe at the Finland Link channel. Hit the notification button for the new videos that will be uploaded. And see you to the next session.